Good evening, everyone. My name is Ginger Sigmund, and I'm the Managing Director of Indie Energy, and I'd like to welcome you to our discussion tonight on artificial food production as a means to combat climate change. Before I introduce our panelists, I would like to remind you that our final Energy Week presentation is tomorrow night by Notre Dame's Assistant Vice President of Utilities and Maintenance, Paul Kemp. Paul will give his annual update regarding the state of energy on campus at 7 p.m. in 136 to Barlow Hall. Our moderator this evening is Professor Peter C. Burns, the Henry J. Massman Professor of Civil and Environmental Engineering and Earth Sciences and Director of Indie Energy. Joining him tonight are three Notre Dame faculty experts. First is Casey O'Brien, Assistant Professor in the Department of Chemical and Biomolecular Engineering. Jennifer Tank, the Ludmilla, Stephen, and Robert Galla Professor of Biological Sciences and the Director of Notre Dame's Environmental Change Initiative. And Paul Winters, the Keough Hesburgh Professor of Global Affairs. If you were at the game on Saturday, you saw Paul be presented with the football on the field for winning a spot on the all-faculty team. So congratulations, Paul. I'll now turn it over to Casey to go over a couple slides, and then we'll bring up our speakers for a conversation.
Thank you for the introduction. So my name is Casey O'Brien. I'm faculty in the Department of Chemical and Biomolecular Engineering. And our research group is focused almost entirely on reducing the CO2 concentration in the atmosphere by developing materials that can pull CO2 out of the atmosphere and convert them into valuable products. So when I started working with CO2, when I started here at Notre Dame about 5 years ago, I didn't quite appreciate this, but the biggest problem with CO2 capture is the enormous scale and cost of the problem. So the current modeling shows that by the year 2050, we need to start removing 10 billion tons of CO2 from the atmosphere every year. Okay, so that's an absolutely enormous number. And to put that into context, liquid fuels, which we consume a huge amount of liquid fuels, the global production of liquid fuels is currently only 2 gigatons per year. So what that means is if we're serious about fighting climate change, carbon capture is going to be the biggest industry in the history of the world, okay, many times bigger than current liquid fuels production. So what we're going to talk about today is what do we do with 10 gigatons per year of CO2, okay? So you can bury it in the ground or bury it in the oceans. There's some significant concerns about the efficacy, the capacity of geological formations in oceans to store that much CO2, and also the cost. But what I think is a better alternative is to convert CO2 into a value-added product to create some value from that waste stream. So the problem, once again, is scale and cost. So ideally, you would want to capture 10 gigatons of CO2 and convert it into 10 gigatons of some value product, except there are no carbon-based products that are currently produced at 10 gigaton per year scales. Okay, so the only two carbon-based products that are produced at even gigaton per year scales are liquid fuels that are produced at about 2 gigatons per year, and then food, which is about 3 or 4 gigatons per year. Okay, so there is some value in converting CO2 to fuel. It's definitely a better alternative than pulling fossil fuels out of the ground. Okay, but what we're going to talk about today is about the potential of converting CO2 into food. So there have been some recent studies that show that you can convert CO2 into glucose or starch, which you can incorporate into staple foods like bread, rice, or pasta. Okay, and when you look at the potential benefits of doing artificial carbohydrate synthesis or food production compared to other alternatives, you'll see that there's definitely a need for more research at the very least, and it could potentially solve a lot of the world's problems. So how are carbohydrates produced? So currently we get carbohydrates from photosynthesis. So this is the reaction, the 6 moles of CO2, which comes from the air, reacts with 6 moles of water, which we get from the soil, with energy, which we get from sunlight. That reacts to form 1 mole of glucose and 6 moles of oxygen. Okay, and so what are the environmental impacts of industrial agriculture? So this chart shows the total U.S. greenhouse gas emissions by economic sector in 2018. And here it shows that agriculture is responsible for 10% of greenhouse gas emissions. So this number is actually at the low end of estimations, and it depends on where you draw boundaries. The upper end of this is around 40%. So industrial agriculture is responsible for 10 to 40% of greenhouse gas emissions. Industrial agriculture also uses about half of global habitable land. It uses about 70% of global fresh water, and it's responsible for about 78% of freshwater pollution from eutrophication. Okay, and the environmental costs of these impacts are estimated to be about $3 trillion per year. Okay, so we aren't currently actually paying $3 trillion per year because we're not actually cleaning up the pollution, but these are the estimates for how much it would cost to clean up the air pollution and water pollution associated with industrial agriculture. And crop production alone costs about $1 trillion per year, which is 170% of the production value. So in other words, it would cost more to clean up the environmental damage from producing the crops than the actual value of the crops. And corn and wheat farming are the highest cost due to land use and water pollution from nitrogen fertilizers. And so the real kicker here to me is that world hunger is currently affecting almost 1 billion people. So industrial agriculture is very bad for the environment, and it's not even sufficient to feed the world's population. Okay, so agriculture is terrible for the environment, and it's economically inefficient, but we need food, and the global population is increasing, which will lead to more hunger and more population. So can we develop an artificial process that produces food, that also reduces air and water pollution, reduces water scarcity, and increases the agricultural capacity of the planet? And I think the answer is yes, but there's a lot of research and development that's required to advance the technology to get it up to 10 gigaton per year scales. So why is agriculture so bad for the environment? And the reason is because farmers use excess nitrogen fertilizers to maximize crop yields. They use too much nitrogen fertilizers, so a lot of it ends up leaching out into the soil and groundwater, which causes water pollution from eutrophication. Some of that nitrogen is converted into nitrous oxide, which gets into the atmosphere, and it has a global warming potential about 300 times that of CO2. Industrial agriculture also requires about 1,000 tons of water to produce 1 kilogram of carbohydrate. It also requires pesticides and herbicides to protect the crops. And climate change will reduce crop yields, leading to more malnutrition. Okay, so why? So industrial agriculture is so bad for the environment, partially because photosynthesis is very inefficient. So this top part shows a brief tutorial on how plants actually capture CO2 and convert it into glucose, for example. So this is a leaf, and this is a cross-section of a leaf. So on the top and bottom, we have the cuticle of the leaf, where the skin is impermeable to gases, but about 5% of the surface area of the cuticle is covered with these stoma, which are apertures that open and close depending on pH and temperature and so forth. And this is what allows gas exchange with the environment. So once these CO2 passes through the stoma, it then diffuses in the interior of the leaf to the mesophyll cells, where it has to cross a cell wall and a cell membrane to enter the interior of the mesophyll cell, which is filled with water. It then needs to diffuse through water to the chloroplast. This is a blown up picture of the chloroplast, and then the CO2 has to diffuse across 2 more barriers before entering the interior of the chloroplast where the photosynthesis occurs. And so there's a series of light reactions and carbon reactions where the CO2 is fixated and ultimately is converted into glucose. Okay, so this is very inefficient. One, because the pathway of CO2 to the chloroplast where the photosynthesis occurs is very tortuous. Okay, there's lots of transport barriers from the atmosphere to the chloroplast where this occurs. It's water limited in arid climates. So this figure shows that the region shaded in red where the Sahara Desert is in Australia. So these are areas where the photosynthesis is limited by water because they're arid climates. And so we don't have much agriculture in those regions. So in the blue shaded regions in the north, this is where the temperatures are very cold. And so photosynthesis is very temperature sensitive and it's only optimal in a narrow temperature range between 30 and 40 degrees Celsius. Okay, so also about almost no photosynthesis occurs in the northern regions where it's very cold. And it's photon limited in the dark, and that's shown here in the green regions here where we have rainforests where the light can't penetrate through the canopy for crop growth. Okay, and on top of that, about half of all CO2 taken in by photosynthesis is re-emitted into the atmosphere by plant respiration, and so this is a catalyst selectivity problem. So the net result of all of these inefficiencies is that massive land areas are required to produce the crops in order to feed the world's population, as well as massive amounts of fertilizers. All right, so the process that I have been envisioning over the past year is shown here. It's an artificial carbohydrate synthesis process that takes CO2 from the air and water and converts it into glucose and oxygen using renewable electricity. So this process is powered by renewable electricity, not sunlight, and this would allow the process to convert CO2 into carbohydrates 24 hours per day, and not only during the sunlight hours. It's temperature controlled, which enables carbohydrate production anytime and anywhere in the world, so not just where the ambient temperature is between 30 and 40 degrees Celsius. It does not require fertilizers, pesticides, or herbicides. So the fertilizers are required in industrial agriculture to produce the amino acids that allow the plant to function, but you can see there is no nitrogen in the glucose final product, so an artificial carbohydrate synthesis process wouldn't require any nitrogen fertilizers or pesticides or herbicides. And also, the process does require water, but only a stoichiometric amount of water, and that amounts to about 1 kilogram of water per kilogram of product, which is much less than the 1,000 kilograms of water required to produce 1 kilogram of crop in current industrial agriculture. All right, so the potential benefits then of an artificial carbohydrate synthesis process are it can reduce water pollution from eutrophication, could reduce greenhouse gas levels in the atmosphere from fertilizers and the Haber-Bosch process, which is used to produce ammonia, but it also produces a large amount of CO2 as a byproduct. It could increase the agricultural capacity of the planet, which would reduce malnutrition and food scarcity, particularly in developing nations. And it would reduce the amount of water for irrigation by orders of magnitude, which would reduce water scarcity. Okay, so there's a lot of potential benefits. The challenges are that it's going to require a huge amount of renewable and cheap electricity, and it's going to cost a lot of money. But when you evaluate and consider all of the environmental costs of current industrial agriculture and crop production, then these costs may outweigh the benefits may outweigh the costs. Okay, and so basically what I'm suggesting here is that we need much more research and development to do the techno-economic analyses and to consider the full life cycle analysis and how it's going to impact societies and communities that rely heavily on agriculture, like in Indiana. Okay, so that's all I have for introduction to artificial carbohydrate synthesis. So.
We'll invite the panelists to join us on stage.
Well, thanks for that fascinating brief presentation. We have here a couple of great faculty members that are probably going to put you on the hot seat a little bit, I think. At least that's what I'm hoping, and that's, I guess, my job is to make sure they do. So, Paul Winters is an expert in agricultural economies and has worked firsthand in relating to food security in different places of the world. So let's start with you, Paul.
All right, thanks. So the first thing I'll say before I give various critiques is that this is a great idea, right? These are things that should be done and need to be done. And I was actually recently in the meeting where they are thinking about what's called advanced market commitments, where basically they put this enormous pot of money out there and say, anyone who can deliver on this, we will guarantee that we will buy it. And one of the things they talked about was to create an advanced market commitment for carbon capture, and in particular, this type of thing. So not only is it a good idea, there's starting to be these what are called pull mechanisms to bring in to get people to do this and to guarantee that they will get money to do it. So it's a really good idea. My comments though are on two levels. The first on the agricultural side and then on the model itself. So one is I actually don't, the strength of the argument doesn't need some of the arguments that Chris is saying, so I'm gonna critique some of that. The first is agriculture, I wouldn't call it inefficient. We managed to get in November 8 billion people on this planet, and we actually have plenty of food for those 8 billion people right now. Using agriculture, using photosynthesis. It has increased in production fairly dramatically. In the OECD, the industrialized countries, we were getting about 2.2 tons per hectare in 1960, and now we get 5.5 tons per hectare. In East Asia, it was about 1.2 hectares, and now it's about 5.0 hectares. So more and more has been getting out of the amount of resources that we have. Now, it is absolutely correct that the manner in which that is done has been done by mechanization, which requires a lot of energy, by fertilizer use, also requires energy and has external effects, and pesticides, which have environmental effects. But we need to recognize there's a trade-off here. We got enough food for the world, but we have these environmental effects. And in terms of the enough food for the world, there is a myth out there that the reason that we have hunger in the world is because there's not enough food. That is simply not true. In fact, I just had a published paper yesterday, a paper published yesterday. I'm on this Food Economics Commission, which is a mix of economists, climate scientists, and nutritionists, and we wrote the framing paper. And the paper that we said, the one thing that's been successful over the last 50 years is the affordability of the food. Food has become more affordable around the world, even in lower income countries. What we've not been successful is environment, climate, ensuring that those that produce are included, the poorer farmers are included, and nutrition has not been great. So we should be careful about what we say and what claims that we make. Hunger, famines are a result of not having access to the means to get food. And Amartya Sen won the Nobel Prize 25 years ago in economics, putting out these arguments. So there's a concern about making an argument that you're going to solve hunger by this type of technology. I hear it with all sorts of technologies, and it assumes that it's a supply of food that's an issue, and it's not. So I would be careful about those kind of arguments around agriculture. Then the second thing on the technology itself, there's one issue that I have with assumptions there. I mean, it somehow assumes that these types of things, including things like vertical farming, which has also been promoted as something that we could do that's more environmentally friendly, et cetera, requires a tremendous amount of energy. And this assumes that you can get that energy from renewable resources. I'm not convinced that's the case. If it was so easy to get renewable energy, why aren't we doing it? Why isn't it? And you guys would actually do better than I would. So why are we not doing it? What's the limitation? And if we could, why couldn't we use it for agriculture to make agriculture more efficient? So it's a little bit of comparing an unfair comparison, saying that you're going to take agriculture as is with all of its problems, and then put the ideal kind of production of carbohydrates through CO2 with the ideal energy source, and it's a little bit of an unfair comparison. So I would just personally be careful about that. I also think that it kind of, you had said something ahead of time that hopefully there's no farmers in the room because I'm really going to make them unhappy, right? And I don't think it's necessary. I don't think you need to make that argument for this to be a very important area of work and something that can contribute heavily to improving the planet. And so we should think of how we can do this and how it in itself helps, can efficiently lead to food production or food uses and not worry so much about what seems to be like a straw person of what agriculture is when this is a viable technology on its own.
Well, thank you, Paul. Would you like to respond to any of that, Casey, before we move to Jen?
So for the first part on there is enough food in the world, but it's just not getting to the people that are starving. And so, and I'm not an expert in this area, but I'm guessing that a lot of people that are suffering from hunger are in areas where there isn't established agriculture because of the climate or some other reasons. And so the advantage of an artificial process is it's not limited by sun or water or the climate. So this process could occur anywhere in the world. It could be in the middle of the Sahara Desert and could address hunger where it's needed, where there isn't agriculture. Just to that point. I forget the second point, but what was the second?
About the use of wind energy for...
Right, so we recently had a paper, a perspective published, and we compared current industrial agriculture to a hypothetical artificial carbohydrate process side by side. And it's true, so the artificial process will require about 10 to 20 times more energy than the current process. And so if we want to produce 1 gigaton of carbohydrates, we estimated that that would require about 8% of the current global energy consumption, which is feasible. Okay, and the reason that there's not so much widespread renewable energy is because it's cheaper now to use fossil fuels, because there's no incentive, there's no environmental incentive. Right now, there's no carbon tax, for example, for using fossil fuels. However, if we do implement these incentives, then the renewable electricity would be more widespread and cheap.
All right, Jen, let's have you weigh in with the ecologist perspective.
Yeah, well, thanks very much for the talk, the presentation, and the ideas. And after Paul, I'm sitting here thinking, my mind is going, I am an ecologist. I work on fresh water, in particular the impact of agricultural practices on fresh water, so how farming in the Midwest, especially very intensive land use, compromises water quality via the processes that were mentioned in the presentation. Nitrogen runoff can cause real problems both in water quality in adjacent streams and rivers, as well as downstream water quality like you see in the Gulf of Mexico or Western Lake Erie. So I'm definitely for a reframing, a modification and optimization of the current practices around industrial agriculture, particularly in the Corn Belt of the US. But I'm not quite all the way to let's do artificial sugar production, carbohydrate production, and just replace it lock, stock, and barrel. I just feel like, again, it's a little bit of a straw person to make a point, but that there's nuance to that. I think it's a great idea, and for really important reasons. Under climate change, our food security is going to become questionable, more insecure, and the most vulnerable in populations across the globe will be affected most. I think population's going up, right? So we are going to need more food to feed the planet. And then finally, I think that resilience under a changing climate, extreme events, unpredictable weather patterns, that makes farming less optimal, less efficient. So there are all these reasons to augment the resilience of our agricultural system. But to just say we're going to go to artificial farming, which is basically build food products in laboratories, really sort of, I feel like, and this is my ecologist part hat coming in, ecology is the study of organisms and their interaction with the environment. So I believe deeply that we, as organisms, human organisms, cannot detach ourselves from the environment and just do it all sort of synthetically, artificially. There are nuances to the natural environment that benefit us. Micronutrients, for example. My first question was, people cannot live on bread alone. Where's the nitrogen in this part of the equation? So I think it's an interesting first step. It's definitely an interesting question to consider, but I don't think it needs to be posed as replacing industrial agriculture across the globe. I work on practices. I think right now we're in a situation where large-scale agriculture is not necessarily optimized for a softer touch on the environment. It could be. Less nitrogen fertilizer could be used. Paying farmers to minimize their impacts on the environment while also optimizing for as much production as they can get. A balance, a trade-off, could minimize what we do on the planet in terms of its negative impact. So I just think that we should consider the idea as a supplement in our toolbox rather than the whole toolbox. So yeah, those were my thoughts.
Thanks, Jen. Do you want to reply to any of that?
Yeah, so I agree totally. I don't envision food being produced artificially anyhow. I think there's always room, you can't make tomatoes or lettuce artificially. So I think that there will always be a huge amount of crop production, cattle, livestock production. I'm just saying that artificial carbohydrate production can be used to increase the food production capacity of the planet, address malnutrition in a more environmentally friendly way. But to the other point, I'm not arguing that this type of process could only be used to produce carbohydrates. So once you have the carbohydrates, you can use single-cell protein, use organisms to convert that into protein with all the lipids and to give you all of the vitamins and nutrients that you want. And that has been a process that has been well established for over 100 years. So people in World Wars I and II used yeast to produce food artificially. Typically it's used from glucose that's derived from starch, but so all you need basically is an artificial process to make the carbohydrates, then use existing single-cell protein processes to convert that into protein, which you can use for animal feed and so forth. And there is actually commercially available products that use single-cell protein. So corn is a product that's used to make a meat substitute entirely artificially.
Very tasty. I've had it.
Yeah.
I enjoyed it greatly. No, that's good context. Yeah, I think I was responding most to the, just the slides that were presented,
Right.
or the argument presented, agriculture is inefficient, and I was just aching for chloroplasts. Chloroplasts kind of beating down evolution. They're
Right.
they're kind of elegant and beautiful as well, so.
But I'm an engineer, so I see the inefficiencies.
Yes, inefficient.
Go ahead, Paul.
Yeah, and I think this is part of, I think what we're saying is that in some ways it deviates the argument, but I don't think we should underestimate the potential need to take CO2 out of the atmosphere. And that we've screwed things up so much and we've gone so far that our attempts at cutting back emissions is not going to be sufficient. And so we have to think of ways to take out CO2. And as you argued at the beginning, which I think is a much stronger argument, these other options of burying it or doing other things, to me at least, are less compelling than turning it into something that might be usable, even with all the limitations you were talking about. That it is one of the options, and one of the things that, at least from my understanding, is being actively explored, and at least philanthropy in the United States is interested in putting a lot of money towards these kind of ideas, and to fund them.
My perspective is that a lot of governments in the world nowadays are making pledges to get to net neutral carbon dioxide emissions by 2050 and so on. But we have no way to get there. On a small scale, maybe at certain communities or something, it could be achieved. But at the world scale, we have no way to get anywhere near there. We're well over 80% still relying on fossil fuels. Unless there's a new technology that we don't see coming. that revolutionizes energy production, we're not gonna get there. So then I suppose the question might be, how much should we focus what energy we do have on reducing CO2 emissions by, well, displacing fossil fuels with all the renewables we can, versus how much should we be using them to do artificial farming to displace fossil fuels in a different way? I don't know the math or how the cycle really works. But, you know, how much energy do you need to make a loaf of bread via traditional, well, not traditional farming, modern farming versus, you said about 10 times more?
It's, yeah, I don't remember it's like 10 to 20 range, yeah.
I suppose it would make sense to deploy in a way that maximizes use of renewables. I mean, even in the United States today, a lot of renewable energy that's being generated is, electricity is being dumped because there's no market for it at that moment in time, and there's no suitable storage, right? So if you had such a facility that could take up the extra energy and do something useful, that would be very positive.
Right, so I have one quick point. So with the paper we just published, so Alex Dowling, my colleague, so he evaluated the CO2 emissions intensity of such a process, even using fossil fuels as the energy source. And so obviously the best would be to use purely renewable energy, but what we found is that you don't need purely renewable energy in order to have net negative emissions. So even California with their current energy mix is close to the type of profile that you would need in order to have net negative CO2 emissions for artificial carbohydrate production, even using fossil fuels.
So the one thing I was going to comment on, Peter, with when you were talking about the options, is really about optimization. I think the issue with any of these large-scale efforts is applying a one-rule-fits-all. So for example, in the agricultural Midwest, it's been deemed that this is the corn belt, right? You grow corn and soybeans here, this is the place to do it. And it's true, we've got some of the highest production per acre in the world is right here. Indiana, Ohio, Illinois, Iowa, don't forget Nebraska. That whole corn belt. But the thing is, within that corn belt are marginal lands. There's always variation. And so I think we sort of need to rethink any of our activities, whether it's energy production, carbon storage, agriculture. Where is it optimal to do X, Y, or Z? And where is it just not feasible? I think that's where I know it's much more complicated. I shouldn't say anything about cost benefit with an economist sitting next to me, and I know it's really complicated, but we should be weighing the nuances a little bit better about where it really makes dollars and cents and environmental sense to do things and where we should retire and move to another option. So I really think a more diversified approach, so it's never going to be an all or nothing. I think it needs to be a diversified approach to our carbon problems. I mean, there is, if I might just add, there is so much pressure coming down the line to farmers to buy into doing climate smart agriculture and buying into these carbon markets. And there's literally the private sector, it has not caught up enough to even market these options to farmers. And they're all sitting like, it's like salmon before they run upstream. All the salmon pool at the bottom of the river waiting for the first to go. And that's what it feels like in the whole agricultural Midwest. Which landowners are going to come in first around climate smart agriculture, carbon markets, but no one knows what to do yet. So I think we really are lacking guidance about how to diversify around, I think, food production, intersecting with carbon, intersecting with energy.
Any more comments from the panel? Well, let's turn to the audience and take some questions.
Give the economist a chance to think.
Back there, does somebody have a microphone? Or should I?
I can just talk loud.
Okay, talk loud.
Can you hear me?
No.
Wait, so is this like, have we been like done before with making the food or whatever from the CO2?
So there's been a few papers released in the last year or two that shows that you can convert CO2 into starch or glucose with much higher energy efficiency than, say, maize production for crops. But these are all at laboratory scale, making like grams of starch or glucose. But the problem is, how do you scale it up to gigaton per year level? That requires new processes, new catalysts that are cheap and reliable.
Does it taste any good?
No one's made it in starch or artificial starch or glucose into food, but it's chemically identical, so it should taste the same. You'll have to add some flavorings to make it into bread or rice or pasta, but the starch itself, they're all basically starch.
I raised that partly, a lot of, as I said, I'm on this Food Economics Commission, and there's a lot of climate scientists and nutritionists. And there's a lot of their assumption is that consumers will change their behavior, right? And that, well, their hope, that we will buy into artificial meat and to get, you know, our Big Macs made out of the laboratory, that we would potentially eat pasta. So Italians will eat pasta. I lived there for 5 years before Notre Dame. So will you convince Italians to eat pasta that's made from artificial carbohydrates? Even if it seems exactly chemically the same, there's an ick factor, right? It was grown in a laboratory. Do you convince them? Will consumers shift to accept these things? The one comment I was going to make, they're all waiting like salmon to jump up because they're waiting to see if anyone's going to buy it, right? You know, there's experiments with limiting climate emissions for livestock at UC Davis, and they basically give seaweed supplements to the cows. It reduces emissions by 90%. And it actually increases productivity a little bit. So you think farmers would jump all over this. When they surveyed the livestock farmers in the Central Valley of California, are you going to do this? Half of them said, yeah, you know, because it's kind of responsible. The other half said, is there a market? Is someone going to buy, you know, belch-free cow milk? Right? So you have a cow that's mouth shut, the birth just comes out, but it doesn't actually leave. Are you going to buy that or not? Is there a premium? And so a lot of this rests on consumers and all of us and whether we change our behavior or not and create markets for these types of things.
Well, I would start with Oreo cookies because I don't know if anyone knows what's actually in an Oreo cookie. So,
Go ahead.
Looking at the implementation of this process, is this operating at a scale that can be used with point sources of carbon, so integrated with flue gas or things like that, or is it for removing ambient CO2 that's already existing in the atmosphere?
So I mean, it would definitely be much easier to use a point source because the concentration is higher, right? So it's an easier separation to do. But the advantage of doing it in the atmosphere is you can do it anywhere in the world where it's needed. Whereas if you're doing it from a point source, then you need to then your factory needs to be at the power plant or wherever that point source is. So obviously, so it would definitely be easier, but there's advantages of having the atmospheric capture.
If you're producing this sugar from carbon dioxide, how are you going to scale back the regular production of sugar that's grown so that you don't have an overproduction?
Yeah, so, well, the demand for carbohydrates is going to continue increasing. And so I don't know how much more capacity we have for crop production. I'm sure you know more than I do. From what I had understood, we're near capacity, but that may be incorrect. But so whatever artificially produced glucose or sugar or starch would be used to fulfill the demand that still hasn't been, the demand that isn't there here now, but will be in the next 50 to 100 years.
Yeah, if I could just comment, I don't think we're at capacity necessarily. I would say that like in a place like Indiana, every square inch that's profitable to farm is being farmed now, and that's just due to markets. It being favorable, land is really valuable here. The issue, I think, is more about will it be favorable to farm here or in a lot of places in 15 to 20 years. They aren't going to be growing corn here probably in 25 to 50 years. They're going to be growing corn in the Upper Peninsula of Michigan. So what I think is a more critical question is as the climate changes, things become less favorable and it's too hard to make a living farming in the ways that we farm now, these types of sort of technological solutions are going to probably be essential in order to feed the planet.
In terms of like policy implementation, would you see this more successful on like a national level from a federal perspective, or like a state-by-state implementation basis, like in the Midwest, like Iowa or Illinois?
Well, I mean, to me, it has as much to do about the technical aspects as anything else, right? Because when you're, generally, it depends on what you're producing, whether it's better to be closer to a market or further away, and it has to do with the bulkiness and things like that. But generally for carbohydrates, for if you're gonna make flour, it doesn't matter, you make it where it's most efficient to make it. And so you wouldn't need to like plan, we need to have a little bit here, 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 and here. It would be more, where is it optimal to produce in terms of energy efficiency? Is it California? Because the energy being generated it would be best in terms of overall carbon. Is there a place where there's more wind? That might be best. So I think it'd be less that. So within a country, I don't think it matters. There's a big issue about other countries and whether they can take these things on, right? I mean, we've had the same, vertical agriculture is taking off in a number of places. Most of those are industrialized countries, so North America and Europe. There's some exceptions. Chile has a fair bit going on, and others. And so, but it's not spreading to the places where we're worried about hunger at all. And so, how do you ensure or facilitate technologies that could be beneficial like this that are brought into other places, and to think extremely carefully about the implications for the local farming population over time and how things work out, right? There's about 600 million farmers in the world, 570 million of them have less than 2 hectares. Most of them are in poor countries. I talked about productivity. The productivity gains in Africa have been 0.9 hectares, tons per hectare in 1960 to 1.1 hectare, tons per hectare. They barely made any gains in 60 years. And so you have a tremendously poor farming population there that you need to be careful about. Now, this can create other kinds of opportunities, so it doesn't mean you shouldn't do it. It means that you have to think in terms of policy, how would you transition the food system to incorporating this type of thing?
Yeah.
In terms of like marketing this as a new form of farming, do you see it competing at all with or working together with the new research on growing meat, like food cells?
Yeah, so I think, the current, I think the protein consumption in the world is much less than carbohydrates. So carbohydrates make up 50 to 70% of our calories, whereas protein is 20 to 30% or something like that. I don't see it as a competition. I think they are synergistic partners. I think that for artificial food, we'll need both, and I think that developing technologies that can convert CO2 into carbohydrates will help in producing proteins artificially as well.
But I also think in general, it's part of the same general trend, right? Can you produce in environmentally friendly ways without too much energy consumption, because a lot of these take a lot of energy, and shift people to eating this type of food, right? Or is it going to be acceptable to the populations to do this? And then it will have effects on the market, right? So if people start eating artificial meat and they start eating artificial carbohydrates, you expect the price of those to go down, so maybe some of the marginal lands to be reduced and hopefully forested again, and then you get the climate benefits. I mean, that's the longer term vision, is if you can get this artificial farming generally going, as it was saying, complementary, then you have an overall shift in how we produce our food, and slowly that will bring about environmental benefits.
Any further questions or comments for that matter from the audience?
Peter, I have a question.
Yes, and please go ahead.
So when I first heard Casey talk, one of the things I thought of was if your methodology was very successful, that over time it would be possible that it would become much cheaper to produce food in a lab. And therefore farmers and fishermen and other people would become unemployed because of market forces, at least in some parts of the world. So I would be interested in all three of you from your different perspectives of, if there were a transition, how would we keep this balanced so that we wouldn't end up with massive unemployment, with people really not having much to do because everybody's, and I realize they may not want to eat the food, but let's say they do, just for a thought exercise. How do you, like, does the government set in, do you let market forces do what it may? What are your thoughts about how you control unemployment that might occur from this climate justice type issues?
I mean, one is we don't expect it to happen overnight, right? So suddenly we're not going to shift from current practices to artificial farming. So it'll occur over time. And so there'll be a time to transition into these things. There is a concern. I think there's less of a concern in more industrialized countries. I mean, right now, about 1% of workers in the United States work directly in farming. It's about 11% in the food system as a whole, but those are all restaurants, et cetera, so they shouldn't be affected. It would be more the direct in farming. So it won't have a big effect. Where in India right now, 40% of people work directly in farming. And so if you could have an effect there. But I would guess that these things will start being explored, like vertical farming, in more industrialized countries. They'll start having an effect on prices, and eventually you'll see this shift that will occur, and it won't be from one day to the next. You're going to have all these farmers without anything to do, but there'll be a transition. That being said, I know I'm an economist, but you shouldn't ever let market forces dictate solely what's going to happen in society. We generally find that economic growth on its own does not benefit everyone. And so, given the poorest people in the world work in agriculture, you still need to think of what is the transition that should occur in those areas in order to ensure that the livelihoods of people are improving over time as this occurs. Part of that Food Economics Commission that I'm on is how do you ensure inclusion in the transformation of the food system and make sure that as we try to meet climate issues and try to meet nutrition issues, because obesity is on the rise around the world, how do we also ensure inclusion that poorer farmers can take advantage of new opportunities? And then we should also remember these are opportunities. These kind of places will hire people and provide jobs. And my guess is they're more likely to be in rural areas just because of energy generation, et cetera. So you are creating other jobs as part of that.
Yeah, the only thing I would add also is I just think that this represents on a continuum, right, of natural to sort of, if I could say, artificial or engineered. And I just don't think you're ever going to beat out of us the appreciation of the natural environment and what it produces with and for us. And so I think that while we may supplement great need and alleviate suffering with our sort of technological solutions on this end of the continuum, as long as there's a square patch of even relatively fertile ground to grow and enhance sort of biodiversity, even if much of it is what we consume as food, I think we're going to do it. We live on this planet. I don't think we're going to forget it's both green and blue, and so I feel like that part of it, and I'm speaking, totally out of my league just as a human being rather than. And I do appreciate like the artificial meat, which I've tried. I mean, it even like bleeds like real meat. It's kind of crazy. I haven't had a burger in a long time, and that was amazing. But at the same time, it's intensive to do these technological solutions to our challenges. And so if we can think of pairing those technological solutions with natural solutions, I think that makes for a more balanced harmony between the two.
Yeah, so 50% of the global habitable land is used for industrial agriculture, so there's an opportunity cost there. So what can we do with that land if we didn't have to use it for industrial agriculture? And so there's lots of opportunities for economic growth in all of that land.
It's interesting, I just wanted to say that coal has has been going out over quite some transitional time, and yet we're still now talking about what to do with coal miners, and can't we just teach them all to make solar panels? So I think there's a little bit of a parallel there, that it's the responsibility of grant money givers to have economists with engineers thinking about these things, and colleges. And not just, you know, as I said, not just to leave it with, hey, this is a great idea, let's go for it. Because I do think that there are some unforeseen downsides that we need to think about ahead of time for once.
Yep, it's a very complex and multifaceted problem, so that's why it's going to require worldwide collaboration from many different fields.
All right, last chance for any, yeah.
So I'm sorry, but I'm kind of failing to see how this could really start to combat world hunger. Considering that, I mean, as we've already mentioned, most food isn't produced where it's eaten, it's produced where it's going to be most productive, and then it's distributed, and it's distributed unevenly, and it's not distributed with the best health benefits because you don't have microorganisms from the environment around people in that food and supporting their gut health and all of that. So looking at especially, like if we're trying to make this a tactic for helping with starvation in like peripheral countries, then how is, how is this better to give them a product imported from somewhere else at a price we do not yet know, and at a quality of food that we do not yet know, than like investing in ways of them improving their own farming and having them farm where they are in what is truly a sustainable way instead of, I don't know, what feels kind of like a last ditch attempt, like, I don't know, drawing carbon from the atmosphere to make artificial food. Maybe I'm the only one, but it doesn't sound like it's really addressing the problem at its root.
Well, one is, what the objective, there's multiple objectives here. One objective is to reduce carbon in the atmosphere, and that should be a key objective. So that is something that a lot of us think is a good idea, and the best way to do it. What that has an influence on farming food and consumption of food, I think the best way to think of it is, as you were saying, is that these systems are by each other. Keep in mind, we're talking about carbohydrates, and as you just noted, there are plenty of calories in the world. The real problem is actually right now nutrition, that you get the right types of calories, and micronutrient problems are bigger than undernourishment, which is a lack of calories. So what you can see, so is it going to, could it help hunger? I think it partly depends on where it's done. If it's done here in the United States, I would guess it has almost no effect on global hunger. If it is done in some of the countries where it would be consumed or nearby countries, then it could potentially by increasing the availability of calories, but it would need to be a system in which that is done simultaneously with kind of natural processes where you get the benefits that you're talking about in terms of food production. I mean, one of the things in this commission that we're talking about is small-scale producers are often in a much better position to produce horticultural crops because they tend to be labor-intensive and don't need as much mechanization. And so they're actually have an advantage to produce those locally for local markets, in which you have the tomatoes and the onions and the vegetables and all of those things coming to market, but also producing by small family farms who can make a living out of it. And you can see how that could work simultaneously. That's something that's trying to pull carbon out of the atmosphere, but producing the basic carbohydrates. I think it would be very hard to get there, but I think conceptually there's that possibility.
Yeah, go ahead.
Sorry. Is there any thought being given, tonight has been presented as more of the, like, it's either the industrial mass agriculture systems or the pulling carbon from the atmosphere and making the artificial food. Is there any thought, like, just in the conversation, because I know nothing of the world, I guess, but like, of trying to find alternative methods that are, you know, the kind of people doing the work. I am not well versed in the subject, so arguably I should not bring it up in a public setting if I know. But you know, like I watched a documentary or two on like permaculture and the benefits of soil as a natural and huge carbon sink, but that's only if you cultivate the soil really well, and you have agriculture that isn't mass production and is not like monocrop, but is more of an ecological setup. There doesn't seem to be any conversation about that alternative whatsoever, and it seems like that's the only one that's really a healthy earth.
I think you're in a better position to answer this, but let me just make one comment first. There is a lot of discussion about that, about agroecological approaches and whether they can be used, and the types of things you're talking about. The question really becomes is, can you do that? Can you take those types of production practices to scale? And can you feed, do you have enough to allow livelihoods, profitable livelihoods for smaller scale producers? Do you have enough to produce for nations, for the world, using those kind of practices? Or would we, if we shift, see a decline in production, and then we do have supply issues which don't exist? I think the jury is still out in a lot of the discussions being asked about that, but you know better than I do, so you can fix it.
I was just gonna follow up. You've made some really great points, and I think we've been, tonight was about putting up sort of a one end of the spectrum, a technological solution, and then how does that fare against some of the other things we're talking about? And your points about alternative agriculture, or even doing commercial corn and soybean row crops in a different way, so they also maximize soil health. The farmers I work with all plant corn and soybeans because that's the only thing you can really make money on around here, and they think about soil health all the time. They know and are thinking about their soil as their carbon, storage mechanism. It's all there, but the thing is, they're also running a business. And so it all comes back to, it does in some ways come back to markets. How can we free up the market or create incentives that free up farmers, no matter what scale, whether they're huge scale farmers or family farms or individual, sort of micro agriculture, can they farm in a way that's healthier for the environment and still make money and make livelihood? So your point is well taken. And I just want to reassure you that there are a lot of farmers, even in the Corn Belt, that are thinking exactly like you're talking about. They want to be climate smart, they want to be carbon friendly, and they want to make a living for their families in the markets that they're currently in. And I am positive, well, I'm hopeful that we're going to get there, we're going to move forward. So be reassured that these are lots of tools in the toolbox. Yeah.
Thank you all.
All right, well, thank you all for coming out tonight, and please join me in thanking the panel.